Okay, let me get back. I was saying that if you provide data which has a different data type, different from the data type you have set for the given column in the table, SQL Server is going to attempt to convert that data into the data for that column. If it is successful, then the data will be entered. If it fails, then you'll get an error message and no data will be entered. What I mean by this is that, for example, you have a column whose data type has been set to date, and then you type a string which cannot be converted to a date. SQL Server will try to convert that string to a date, and after it has failed, then it will bring an error. But if you have entered a string which has digits inside it, and those digits are corresponding to the 4 digits for the year, 2 digits for the month, then 2 digits for the day, SQL Server is able to convert that into date data type, and you won't get an error message. Okay. So the point is, make sure that the data that you provide should be of the same data type as the data types for the columns. Particularly, you have to be very careful with numbers with the floating numbers, that is, numbers with fraction parts. Those can give you a lot of error messages or just wrong information. Okay. So when you are inserting data, you just have to make sure that the data type is correct for each column that you are going to enter data into. I have a simple table here. This table consists of 4 columns. These columns are employee name, employee number, employee address, and salary. But what you are seeing there is just the structure of the table. So in the first column, that's where I've put column names. Then in the second column, I've put the data types assigned to each of those columns. Then the third one, I've indicated whether a null value will be accepted or not. Okay. This is an example of a number of statements that I've used to insert data into the table. If you look at the first one, I've left out the column list. So what it means is that the first value, which is the name, is going to be assigned to the first column in the table, and the second is going to be assigned to the second column, and the third will be assigned to the third column in the table, and the last value is going to be assigned to the last column in the table. But the second example is where you have a column list and the data values. When you have the column list, you have the liberty to change the order in which the values are going to be presented. So the only requirement in this case is that the number of columns here should match the number of values that you have given in the values list. The third example illustrates a case where you want to change the order or the sequence of the column, the values that are going to be entered into the table. For example, you may be more comfortable with starting with the employee number and then the salary, then the address, and ending with the name. If you want to do that, then you have to make sure that the column list should be arranged in this order to match the values that you are going to enter. So let me go back to this and create this table. Then we go through these examples to enter data into that table. So I'll switch to okay, I've switched to my management studio, and as you can see, I'm going to start by creating this database. I removed the one which was there. So I'm going to create a new demo database. And then I will switch to use the new database. Then I'm going to create this table for employee data. This table is going to consist of these 4 columns. And these are the data types that I've listed here. And there are some constraints. I've set the primary key to this one. Okay, so I'll go ahead and create this table. And to just see the table which has been created, I'll run this statement, select statement. So we can see that although the table has been created, it is still empty. Okay. Then I want to insert data into this new table. The first one is here. I'm going to insert the data without including the column list. So I have to arrange the data in such a way that the first value will go into the first column. The second value is going to go into the second column. The third value is going to go into the third column. And the fourth value is going to go into the fourth column. Okay. So I can go ahead and execute this one. Okay, so I can go back and check the data in the table by executing the select statement. So I have 1 row in my new table. Okay. The second row I want to insert is this one. I've indicated both the column lists and the values list. Okay. So now I should have 2 rows in my table. Okay. Next, I want to insert the third employee. Now for this one, I want to start with the employee number, followed by the salary, then the address, then end with the name, employee name. So for me to achieve this, I need to arrange the column names in the way that corresponds to the order of these numbers. Okay. So if I run the select statement, you see that although I had started with the employee number, which is 103, it has been placed in the second column. And the salary, which was second here, has been placed in the fourth column because SQL Server is going to follow the names of the columns and the order in which I have listed them. Apart from inserting single rows at a time, you can also insert multiple rows into a table. All you need to do is to start just like we have been doing before. You list the column lists, then the values you indicate in brackets. After that, you put a comma, then another set pair of brackets and put the values in that. You do not repeat the word values. The word values should only appear once, and after that, you only put a comma after each pair of brackets. Okay. So here I'm going to insert records or rows for these employees all at once, so that although I have inserted 3 in the previous statements, I can insert 3 more all at once. So now if I go back and use the select statement to check, I'm going to have 6 employees in my table. So that is inserting data into a table. You can insert a complete row at a time or complete rows at a time. But you can also insert values in selected columns. To do that, you have to bear in mind the constraints that you have set for your table. So for example, if I've set a column to be not now, it means that I cannot insert values in that. I cannot insert values in a row unless I've included something for that column. Okay. Particularly, this is true for the primary key. So here I want to just insert the name and the employee number and leave out the address. Maybe the address is not available, or we don't know the address yet, or it's not clear, we need to consult, as well as the salary for this employee. So we can go ahead and insert just those values into these 2 columns. So now, when we check our table, we see that the last one has only these 2 values. Elsewhere, we have now values inserted. Okay. Again, I emphasize this. Bear in mind, when you have to enter partial data, always remember that the constraints must be satisfied for each column which has a constraint. So I want to insert another row for this employee, and for this one, I'm going to include the employee number, the name, as well as the address, but I'll leave out the salary for this employee. So if I execute this one, it's going to work because the only constraint I've set is on the primary key. But if I was to change the table, to alter this table and include this constraint that the salary should be greater than 5,000, and I attempt to insert this one, this statement is going to fail because the database engine is going to check and see that the condition set for the salary column has not been met. The salary column, if I've set this constraint, should never be 0 or any number less than 5,000. Okay. Here I have got another employee. This one, I'm going to insert the employee number, the salary, and the name. So I'll go ahead and do that. Okay. Okay, so we get an error message. If we were to check, we'll find that we have already set the primary key. We have already used this primary key for a different employee. And since we have not set this column to identity property, the database engine is not assigning the numbers automatically. So it's up to us to make sure that those numbers which we are entering are if there is repetition, if there is a duplicate, that data entry is going to fail. So I'll go back and modify this one and say maybe 114. That has been successful. Then I can now view my table. So we can see that this one, we have now value for the address, but it has been inserted in this table. So that's about inserting data into the table. You can insert complete rows. You can insert partial data into tables. But when you are using partial data, always remember that the constraints must be satisfied. Otherwise, that attempt will fail. Okay, let me go back to the PowerPoint presentation now. Okay, so we have gone through those examples. And I've illustrated how you can enter multiple rows at once. You have to indicate the values in groups and put them in brackets and separate them by commas. These commas can be anywhere at the end there or at the beginning of the next line. It doesn't matter. But as long as the comma is in between the closing bracket of the last group and the opening bracket of the next group. There are times when you may need to insert data into the tables that have relationships defined for them. For such, you need to start by entering data in the table which has the primary key. Then you can move to the table containing the foreign key. I hope by now everyone is clear about what a primary key is and what a foreign key is. So let me illustrate this aspect before we go to updating data. Again, I'll go to my student management here. Here. So I'm going to create a new database structure. I'm going to still use the same database, this one, demo DB2, but I'm going to create additional tables and I'm going to create relationships between these tables. Now, maybe before I do that, I show you the relationship I want to establish. So for this demonstration, I'm going to have a table called customers 2, which is going to have a number of columns. I'll just pick the key ones. I'm going to have okay. Then I'm going to have another table called products 2, and this one is going to have product ID, then product description. Then I'll have another table called orders 2, and this one is going to have order ID. Then there will be order date. Then there will be customer ID. Then the last table is going to be for order details. Okay, this one, I'm going to have, what I want to do is I'm going to have information connecting to the different tables here. So I'm going to have cast order ID. I'm also going to have product ID. I'm also going to have things like quantity, and so on. Okay, when it's 40 minutes, we'll take a short break, then we're going to just resume again, okay? So let me continue. So I'm going to I want to draw some, okay. So I'm looking for shapes. So I'm going to have a relationship between this table and the orders by linking this to this one, okay? Then for the orders, I'm also going to have from product, okay, this is going to be, I hope you can see, bear with me on that, okay. So no relationship with this one, it connects products to order details. Then I also have a relationship between the orders and order detail there. Yes. Now, for this table, I need to find a way in which I can set the primary key. So I'm going to put this one, order ID, as a primary key. But then here, then I have to find a way to set the primary key. I'm going to combine these two to form the primary key. Okay. Here I'm assuming that each customer can order a number of products, and the number of products can be ordered by different customers. So to bring those two together, I have created an additional table in between those two tables. And so this table is helping me to connect this, this one to this one, and also the customers to the products, okay? So now I'm going back to the management studio and be able to create those tables. So the first table is this one for customers. I'm going to have these as my fields. And then for the tables, I've got the following columns. And this is for the orders. I've got these columns. Take note, that's the primary key. Here, I've set this one as a primary key. And here, I've set this as a primary key. But I also have a foreign key, this one, customer ID, to connect me to the customers table. Then the order details is going to have a primary key consisting of two columns, the order ID and product ID. And it's going to have two foreign keys to connect to the products table and orders table. Okay. So I'll go ahead and create this. Okay, so I'll go ahead and create these tables. And we can check our database, refresh. And open it. So we have these tables, that one, excluding this one. These have got a relationship. If I go to database diagrams, and that's the structure I've created for this database, okay? So I want to use this to illustrate how you can insert data into tables which have a relationship. So we said that when you are entering data into tables with a relationship, you have to start with the tables which have the primary keys. Once you have done that, then you move on to the tables which have the foreign keys. So I'll go back to here. So I'll start with the products table. I'll enter these rows, 1, 2, 3, into the products table. Then I'll go to the customers table and insert these customer details. Once I've done that, then I can go to orders, because in orders I have a primary key and a foreign key from customers. I can't go to order details because in order details, I need the order ID, which I've not entered into the orders table. So I'll start with this table. Then I can go now to the last table and enter the data. Now I'm able to query all these tables and check the data in them. Okay. If I try to enter data where there is a foreign key before I enter the data in the primary table, I'm going to get an error message. Okay. because for a foreign key, the value must exist in the primary table before you can use it. Okay. So that's how you can insert data into tables that are related to each other. Okay, I'll pause for questions. Are there any questions?
Yes, sir.
Yes.
I have a question.
Yes.
On what inserting data, because yes, I have seen another way of what inserting data, whereby you just say values once, then you continue with the strings down there. But I also have a question on that kind of inserting data using the command union O. Is it okay to use also that one when you're inserting data? Because I saw in a certain video a tutor was using that same one, union O. Union O select, then the data, then union O again select. Is it okay if you use that one, or it has some impact, or does it also bring up some changes in the table that you have created?
Okay. What you're referring to is a case where you are using a nested query, a subquery to provide values to be entered into the other table. A union clause is used on nested queries. It is used to select records or rows from a table. We are going to look at that. I deliberately skipped that one. We'll come back to that when we have gone up to chapter 10. Okay, to look at the union and see how it works. It has no effect on the data entry. If you remember the syntax I showed you, this syntax I showed you, there are three possible sources of data that you can have for an insert statement. You can have actual values like default. You can have a value list, the ones that you put in brackets, or you can have a subquery using a select statement, which can use a number of clauses such as the union or even the in state clause. So any of these can be used as the source of the data to be entered into that table.
Okay, I
the
understand.
only effect is going to determine what kind of data is going to be entered. I don't know if that has answered your question.
Yes, yes, I've understood.
Okay. Any other questions or comments?
Yes, sir. Does what you just did qualify as a join?
Sorry, come again?
When you're linking the tables, does that qualify as a join?
Joins are only defined in the select statement. What I've done is I've established relationships. But of course, joins would depend on the relationships, and I'll be showing you in a moment.
All right.
Yes. Any other question? Okay. Okay, let's go back to the management studio and look at the data entry process. I've entered the data. Now I want to use some of the concepts that we have looked at to be able to retrieve this data from the different tables. The first statement here, I want to retrieve data from the products table, from the order details table and the products table. And I'm going to pick the columns for all these details here. Are we clear on what that implies? As I've set aliases for the tables, OD is referring to the order table. That's what I've done there. Then I've created an inner join with the products table, this one which I've named P, and the join is on the relationship created using the product ID from the order details and the product from the order details and the products table. So we are using that relationship for this inner join. Now the idea here is I want to retrieve information. The information would be more complete if I'm able to retrieve from different tables. What I mean is this. In the products, in the order details table, which is this one here down. Sorry, not this one. That's the order details table. It's just showing numbers. I may want to see the product description. This product 200, what is it? So I may also want to see what's the price or the amount to be paid for this product. Okay, so to do that, yes, Anton.
Yes, sir.
Yes, you can go ahead.
I just wanted you to explain a little bit more on the aliases. I was a little bit behind there.
Okay, I think it's because when we looked at this, you were not there. Basically, aliases are names which are used instead of the table names. You can create aliases for columns. I'll be showing you even in this example. You can also create aliases for tables. The idea is when you are using a select statement in a join, you are going to involve more than one table, and some columns are going to be found in both tables or in some of the tables. So the database engine will need to know each column that you want to retrieve, from which table does that column belong? So we can either use the actual names of tables, but that would be very cumbersome because the table names can be long. So to shorten the statement, we can use aliases. Aliases are like nicknames. Okay.
Okay.
So what I've done here is this order table, order details table. I've given it a, let's say, a nickname of OD, so that when I come here and say OD dot star, I'm simply saying I want to pick all the columns from this table called OD, which is order details. When I come to this one, where it says P dot product description, I've named this table products 2 as P. So when I come here, I want to pick this column found in the products 2 table. Or when I come here, the first product ID is coming from the order details table. The second product ID, the column name is the same. But this P is indicating that this column is coming from the products table. And this one is coming from the order details table.
Okay.
For columns, the syntax is the same. You can use, after the name of the product, you can just put what you want to use as the alias, but I recommend that you use the keyword as to avoid mistakes. So if I was to remove that, it will still work, but this is prone to some errors, okay? So that's why I consistently keep using this word as. The same can be said about the columns. I've created a new column, this one, which I'm going to obtain by multiplying the quantity by the price of that product. This client has ordered maybe 10 items of a certain product. I want to determine how much has to be paid for those 10 items. So to do that, I'm multiplying the quantity from the order details times the price which is found in the products table. Now, since this is a calculated field, it has no column heading. So I give it a column name, which is this one. So this is an alias for this table, for this column that I'm going to, which is going to result from this calculation. Is it making sense?
Yes, sir.
Okay.
Yes, sir.
Okay. So
Yes.
that's the query I have. I've used an inner join to retrieve information from both the products table and the order details. And I've created a new column to determine the amount to be paid for each item. So once I've executed this, you can see that I have here at the end the line total, or I could have said amount. Okay. So what the database engine is doing is it's taking this quantity, which is coming from the order details, and multiplying it with the price coming from the product table and giving me that. So this one is, the quantity is 4 and that is 240. So altogether, that's 960. Here is one quantity, and that's what we get there. Here is two items at 950, so we have 1,900. Here is one item at 240, so it's 240. The point I'm trying to make is sometimes to retrieve data which will make sense to the people using the database, you need to retrieve data from multiple tables. And this is one way you do it. Now, the next example involves using more than two tables. This one, we want to retrieve data from the customers table. We want to know which customer ordered which item. And we also want to retrieve the date on which the order was made from the orders table. Then we also want to obtain the amount, which will be calculated by multiplying the quantity from products table and the quantity from orders table. So we have four tables, all of them being accessed using this a set of joins. Okay. So the way I've done it, I've started from customers table here. I link this one to this one on using this order ID. Then the results I get, I link it to orders details using that ID, order ID, order ID. I cannot link customers straight to this one because they have no relationship between them. I need this relationship to obtain the order ID. Then I use this order ID to obtain data from there. Again, I cannot connect the products to customers because there is no relationship. So I use this order ID to connect to this one. Then from here, I connect using the product ID to this product ID. Okay, so that's how I've done it. So I have the customer table, I've named it, given the alias C. The orders table, I've given it the alias O. And the order details, I've given it the alias OD. And the products table, I've given it the alias P. Look at the way I am doing it. I tried to put it in this way so that it will help you to understand. Here we are indicating the type of join from customers to orders. We are using an inner join. And this is being executed on this relationship. To connect to orders table, to orders detail, I use this one, orders ID from orders and order ID from order details. Again, to connect order details to product, I'm using that relationship, product ID, product ID. And in this one, I have decided when I multiply that, I'm going to call it amount. Okay. So that's my column there, amount. So we have information. This information, the column, first column is coming from customers table, as well as this one. Then the order ID is coming from the orders table and the date. The price is coming from the product table. The quantity is coming from the order details table. And this is a runtime column, a column which is, the data in this column is not being saved in any column. It's just being calculated at the time that I run the query. Remember, one of the key concepts of databases, relational databases, is that we want to preserve data integrity. Suppose I had in my customers table, I had the date of birth for customers. Instead of looking at the actual age of the customer, which may become updated at some point, I can calculate the age at the time of viewing of the query. So that if someone was born on May 15th, 2000, if I ran the query yesterday, it will show a different age. If I run the same query tomorrow, it should give me the updated age of that customer. Any questions? Any questions?
Well, sir,
Yes.
you talked of the amount section. The amount section, I
The
seem to have
column
forgotten a
amount
little
for
bit. Can you just
amount.
yes, how it comes about?
Sorry, what's your question?
I'm saying I just want
This column.
you to explain a little bit on how it comes about, like
This
how
column.
it originates. Yes.
Okay, you have seen this part here.
Yes.
What I'm doing is for each item, for each row in this table, or sorry, in this query that
Okay.
I'm retrieving in the results, I'm multiplying the price, which is
Okay.
by the quantity for that
Okay.
for that row.
Okay.
Yes. I don't know if that answers your question.
No. Okay. My question was how it automatically runs that without mentioning it in the query.
No, it's mentioned. It's here. I've
Okay, that's
added it here.
okay. Okay. I didn't see that. I missed that part.
Okay.
Okay.
No, it's here.
Okay. Okay.
Any other question?
Yeah, man.
No question.
Okay, so that's about the insert statement. It's the that's the bulk part of this section. The other two are update and delete, and I quickly want to go to that. Okay. Okay, so now the next, I said In data manipulation, we have the insert statement, update statement, and delete statement. Okay, so I come to the second one, which is the update statement. Update statement is used to update data into which already is stored in a table. Update statement is not used to enter new rows in a table. You use it to modify existing data. For example, if we have a customer table and this customer happens to have moved or changed their shipping address, we'll need to go into our database and update the address for that customer. Or it could be that when we have a table containing products and showing us the number of items in stock, when an item has been sold, we'll need to adjust the number or the quantity available by reducing the number in stock by the number that has been bought. So to do that, you use the update statement. But update statement can also be used where in cases where mistakes were made. For example, a customer's name was misspelled. To correct that, we can use the update statement. Or we can use update statement in cases where some values for some columns were not provided at the time that the data was first entered. We have information about a customer, but that information, maybe the address is not clear on the form, or we just don't have the address. We can enter, like we saw, the partial data, leaving out the address. When the address is available, then we can use the update statement to insert the address for that customer. But it's important to emphasize that update statement is used only for data that is already in the table, not adding new rows. Okay. The syntax is like this. Update followed by the name of the table, then the keyword set, and the column that is going to be affected by the update or to be modified, and the equal sign. In this case, this sign is said to be an assignment operator. We are not comparing these two values. We are assigning whatever is on the right-hand side. That's what we are setting to be the value of this, what is on the left-hand side. If we are going to use to update more than one column, then we just need to put a comma, then the next column equals the corresponding value, and so on. The last two, as you can see, they are in square brackets, meaning that they are optional. So all these, starting from the third up to the end, they are in square brackets. It means that these are optional. The statement can be executed with just the first two lines. Okay. Now, table name here is referring to the name of the table, this table, which is going to be
Course
updated.
trinayo ndiye programming course ya coding.
Column name, we are referring to the column that we want to modify inside this table.
I think 19.
Then the value is what we want to assign or save in that given column.
Inentengi out my points.
Okay.
Let's explain something. Anyway, manja.
From table
host things
is a clause that is used when you want to update data
especially
from
programming in different
a table.
And tupaza kocheka.
Okay.
Nzambo mkarana tubanda usiku nifuna which time improve maningi ucha program. Kai goodness ya programming ningasebenze nangususebenze na muntu. Wake.
I'll mute you so that your voice doesn't compete with mine. So I'm saying the statement here, the clause here from table name is an optional parameter that you include if you want to take data from one table and use it to update another table. And in most cases, the update statement will require the use of a where clause to put a condition. For example, I could have a table called employee data, and there's an employee called who has, maybe the name was Mlonda, and it has come to light that this name should be Mlonda Mono. So to change that, I would use this statement. Set the column I want to change and the value to be assigned to that column. And the comment, sorry, the condition is I want to look for an employee whose employee number is 102. If I don't include this condition, all the employees in this table, their names are going to be set to the same value. Okay. Again, I need to point out this. The update should be in line with the constraints that you have set, the integrity constraints that you have set for the columns in your table. If one of the constraint is not satisfied, is not met, then the whole update process is going to fail. There will be a rollback, meaning if the first maybe two columns had already been changed, then on the third column, the constraint has not been met, then the database engine is going to reverse what was done to the first two columns to the way they were before it started updating. And that's what is called rollback. Okay, so no row is going to be affected if one constraint is violated. A few guidelines, just two guidelines for updating data. An update can only be done on one table at a time. You cannot update data on multiple tables at the same time. The second guideline is that the updates should not violate any integrity constraint. Otherwise, the whole update is going to be rolled back. so that the table goes back to the way it was before you started the update process. Okay, I have got an example in here. This is from the Adventure Works database. We have, okay, let's go to the, okay. You recall we have this table and we have some I run the query. So this one doesn't have the value there. This one doesn't have there. This one doesn't have there. This one doesn't have there. So if we wanted to set the address for this employee called Moses Kosa, what we'd do is would say would say update the name of the table, imp data, and then we say set imp address equal to then the data or the address that we have received. So if the address say is 127 Independence Avenue, Woodlands. Now, if I was to run this query as it is, it will change the address for all the employees in this table. So I'll have to put the clause statement, the clause for the where clause, to put a condition to say, I only want to update the address for the employee whose employee number is equal to 114. That way, it's going to search this table and find this employee and change that address. So you can see that now we have the address there. Suppose we are told that we have misspelled the name there. Sarah is supposed to have H at the end. We can use the statement update imp and say set imp name equals Sarah and call it. Again, don't forget the where close. Otherwise, everything is going to be changed. Where, since she's the only one, I can still use imp name is equal to Sarah, call it. Here, if I want, I can use wildcards. Remember to say I want to only update records for all the customers who are in maybe whose surname starts with M or something like that, or whose first name starts with the letter P or the letter M or J or something like that. You can still use that. But typically, when you are using update, the update statement, you want to make sure that you pick the exact row that you want. So if it's just one, the best option is for the clause there, the condition, you use the primary key because that one is always unique. Okay, so I will go ahead and execute that. Then I can now see the changes. So that has been changed. If we have information for the address for this one and the size for this one, again, we can go ahead and do that. So we say update imp data, set imp address equal to 21 Entebbe Road, North Rise, comma, I'll go down. I can put on the same line, but I just want to go down. Then the salary is maybe 18,900. So I'm going to put the address and the size for this employee. Now, before I do that, I need to put the where clause, where imp I number is equal to 121. Otherwise, if I was to run it without this, all these employees are going to have the same address and the same salary. Okay. Okay, so that's about this update statement. Any questions? Any questions?
No, it's clear there.
Okay, okay. Unfortunately, we have run out of time.
Okay.
We have a few things. If we go back to the presentation, which you should have, the next is the delete statement. This one is used to remove data from the table. Remember, this statement is never used to delete data is never used to delete objects. For example, deleting the actual table. It's only going to delete rows in the table. And this is the syntax: delete Again, from is optional, followed by the name of the table. And then again, this also is optional, where it says from tables or table and where condition. The same principle applies here. If I want to delete the row for a certain customer, I just use delete customers, the name of the table, where I put a condition, customer ID is equal to 4. If I'm deleting data from related tables, I'm talking about tables where there is a relationship. Remember, when inserting data into related tables, we said you start by inserting data in the table with the primary key. Then you move to the table with the foreign key. For deleting, you follow the reverse order. So you start by deleting where there is a foreign key, then you proceed to delete where there is the primary key. What I'm saying is this. Want to go to Management Studio. We did this query, and we said that okay, product and so customer orders. Okay, so customers and orders. So we have these two tables. If we wanted to delete the record for this customer, Kelvin member, I cannot delete starting from here. I have to start by deleting from this table so delete order it orders orders, okay, order 2, and there I want to delete where customer ID is equal to 103. Oh, sorry. This table also has something linked to that. So if I have to do it properly, I have to start from this table, the order details table. I delete any reference that corresponds to 103 in there. Okay, let me do that. So I will I will have to delete from this table. And from this table, for this customer 103, no, Now we need to see how it moves from. So I have to trace from the. Okay. So from customer 103, then we have 103 there, 103 there, and the ID, customer ID. So we need to get the ID from here, which will be this ID, order ID, and this order ID. And that's what we delete from this table. This order 1, 6, and 4. Once we delete these two, then we can come here. Once we delete 4 and 6 from here, so in this one, this is the order details table. This is the orders table. So here we want to see where there's 103, 103. So we have to delete this one, this one, this one. And that's 6 is not there. So it's just 4, this one. So we need to delete those. Then we can come here and delete this one and this one. Then from here, we will go to the orders, to the customers, and delete that one. So you follow the reverse order from inserting. Inserting, you start by inserting where the primary key is and end where there is a foreign key. For deleting, you start where there is a foreign key and end where there is a primary key. Okay, any questions? I need to wind up now. Any questions?
Sir,
Yes.
you are saying to say, can you just repeat the statement that you made when deleting and inserting?
I said for inserting the guideline, one of the guidelines was that we start by inserting data in the table that contains the primary key, then move on to the table that contains the foreign key.
Okay.
But for deleting, it's the reverse. You start with the table that contains the foreign key, then the table that contains the primary key.
Oh, so in short, inserting and okay, can say insert is the opposite of delete or the other way around.
Yes.
Okay.
In this case, they are opposite.
Okay.
Yes. Yes. Any question?
Yes, sir. I wanted to find out in a situation whereby you mistakenly delete a law that you were not supposed to delete.
Yes.
Is there any chance of bringing back that data which you have deleted?
Yes, there is. It just that I've run out of time. Let me show you this. This, if you check this slide, starting from the 24 going downwards, I've summarized the points about that.
Okay.
Yes, when you delete data rows from a table, the rows which have been deleted are going to be entered into a virtual table called deleted.
Okay.
And you can access that table, for example, using this statement. So this one, you delete, okay, this one is for updating. If you update the rate from a certain value is 8.5, you update to that. It's going to be, that change is going to be saved in a temporal table called deleted. And when you go there, you can access the record. The same applies to the delete. If you delete maybe this employee with number 4, you go to the output deleted. This is going to contain the details of that employee who has been deleted. Does that answer your question?
Yes, sir, it's clear.
Okay, okay. So please take time to go through this. Where you have questions, you have difficulties, you can contact me. Next week, like I shared, I'm going to move on to chapter 6 and look at views, indexes, and full search in SQL Server.
Okay.
Oh, sir,
Yes,
just one more question, sir.
yes.
The rating. Can you just highlight a little bit more, just quickly through the rating? I missed this point.
So,
The set rate.
I don't know. What do you mean?
I'm saying, can you just explain what you said on the rate, the setting of the rate? What is the rate all about, in short?
Oh no, I'm just giving an imaginary case where we have an
Okay.
employee data table containing a column called rate.
Rate.
Maybe
okay.
there are employees who are paid hourly, and so when you need to update the hourly rate for that person, you can find the column which has been affected in this table. And the idea is, because you may need this information in future or for accounting, forensic, or auditing, you can create another table which you are going to call employee data archive. So once you have updated data for this employee whose employee number is 4, you are going to access it and use this statement to send this to a new table, which is called employee data archive.
Okay.
Yes, that's what I meant.
Okay.
Yes. All right, I'll stop here. I'll see you next week, but please feel free to send me questions if you have questions, and please go through the work I've sent you and also the books. You can go through the books because I've not given all the details. You need to be familiar with those details and you need to practice as you prepare for the exam. Because if you don't do that, you are going to most likely forget some of these things in the exam. All right,
Okay, sir.
we'll see you next time.
Thank you very much, sir.